Hey, good afternoon, Matrix4 people. This is Teacher Red, and now I'm making a new video. I already checked my microphone. I'm already I'm already like stupid yesterday, so today I'm not gonna do it again. Okay, so let's talk about what I did to what I did for you yesterday again, man. So let's take it out, right? Yesterday we started at here, so let's take it out. I explain again. So 1.15, we want to talk about an inverse property of multiplications. Let's see. So this one, let's start with this. If you have like a inverse, right? And it goes like inverse again, it will come out to be just a, this one is so simple, like you don't want to spend a lot of time there. So if it's explained to you, it's gonna work like something like negative of negative comes out to be like positive. So right, you have an inverse, and inverse of an inverse is back to be the original again. Okay, next one, this one is so easy as well, right? This one, a power minus one, and then all of them just power with n again. So you can swap, right? It's say like you can swap. You can just swap that upper script, right? Just want a number on top, or we just call it like index, So you can just swap the two like indexes like that, and then at the end it is equal to the eight. It's equal to a power negative one. Right? The next one. Um, if I want to put a star, right? So everyone, like if I want to put a star, I'm gonna put it at here. AB power minus 1, right, is equal to B power minus 1 times A power minus 1, right? Or I would just say like AB inverse, AB and inverse, right, is equal to B inverse times A inverse. Yeah. I want to highlight this one because many students make a mistake, right? They just go like this, AB inverse, right, is equal to A inverse, B inverse like this. Yeah, no. You don't want to do that, right? If you do this, it's wrong. So don't do it. You will be somebody that will not make a mistake on something stupid like this, okay? So next one, k times a, and all of them inwards, right? K times a, all of them inwards. That thing is a constant, that thing is a scalar, k is a scalar. So it comes out to be like this. So you can say like this one is so simple, like -1 which is go to k, and -1 which is go to a. So k power minus 1 is just that, 1 over k times a inwards. Like this one is so simple, straightforward, right? And next one, uh, det of A inverse. Det of A inverse is going to be equal to that det of A, and all of them power minus 1. Okay, det of A inverse is det of A power minus 1, right? And when you have a power of minus 1, you can just flip it down like that. Right? So you have 1 over det A. This one is very important too. So if you want to be good in matrix, then you have to remember the two of them, right? You have to remember the third one and the fifth one. You need to know both of them, right? Next, we're gonna go for the remark. Right? Commutative property doesn't hold the product of matrices. Yeah, what's the meaning of that, right? So you look at here. I think that I taught you in a class a little bit about this one like today, because we did some pad exam, right? We did some pad 1 exam in a classroom. And let's say if you want to get B alone, right? You want to get B alone. A times B is equal to C, right? So you have to multiply A inverse in front of A, right? And the other side, you have to multiply with A inverse as well, right? And then it goes out, this can be cancelled with that, and it will produce an I, right? An identity matrix I, and I times B is just B, and then you have it equal to something like that. B is equal to A inverse times C, but somehow B is not going to be equal to C times A inverse, because it doesn't have the commutative properties. Commutative, like I told you, like something like this. C, right? C is like change, and then O is the order, right? So in matrix, you cannot change the order. You cannot change the order. Order is so important, right? AB is never equal to BA, but sometimes I can correct. I just correct myself. AB is not always equal to AB. Yeah, it's not always equal to AB. So what should I say? Like if You write AB like this, and then you multiply A inwards to the back like this. And then this side you have C, right? You multiply A inwards to the back like this. I would say that this is not going to be equal to this one. So be careful. Be careful. This is not okay. This is not okay. So be careful. Don't make a mistake, okay? This one I pointed out. It's a common mistake for many students. Maybe like 1 million students made a mistake on this. You're not gonna be student number 1,000,001 who are going to make a mistake again. Uh-oh. What is this one? Let me take the old one out, the one without the sounds. The one without the sound. Oh damn! Like I'm a little bit like, I panic a bit because I'm so afraid that I'm gonna talk alone again. I mean, like I'm gonna just like have no sound again. I'm just a little bit like panic. Okay, so let's apply what we know into this problem. Applying it, guys. Here you have like big X, right? This one is the big X. So big X is a matrix, right? Big X is a matrix, so it has like the dimensions, it has the row, it has the columns. So if you want to find this matrix, then you have to go somehow like this. Okay, 2, -5, 1, -2, right? And multiply 2x. And you want to move this one. You want to move this one to the other side. Okay, so you can have like 3, 0, 1, 2, and then this is plus, right? This is plus. You move it there, it becomes like minus. It becomes minus. So you have 1, 2, 2, 4, something like this. Okay, and you just do the simple like matrix subtraction. It's so simple. Okay, 3 minus 1 is 2, 0 minus 2 is -2, 1 minus 2 is -1, and then 2 minus 4 is -2. Okay, something like this. And now you want to find this x, right? You want to find this x, so you have to multiply this x with, oh no, not just multiply the x. You want to find just x alone, right? So you have to multiply this one, inwards of this one, to both sides. You want to find, you have to multiply the inwards of this one to both sides. Inwards of this one to both sides. So let's have some working space out here. So let's find inwards of this one. You're gonna find inwards of this one, okay? So I'm gonna call it A. Okay, if I call this one A, I'm gonna call it like A. So I'm gonna have to do something like about A inwards and get it done there. So A inwards is going to be 1 over det A, right, times adjoint A, times adjoint A. 1 over det A times adjoint A. So we go now. So det A, if I want to find this det, right, cross down is -4, cross up is -5. So I'm going to do down minus up. I get -4 minus -5. I will just get number 1, right? I would just get 1. And adjoint A, if you want to get adjoint A, you have to do something like this. You have to swap the two members along the diagonal. So there's 2 and there's -2, right? We just have to swap it. So -2 will just come up there and 2 will just go down there. Okay, so you should see it. And next one, right? So not along the diagonal we have this one, and that is -5. So we have to swap not the position, but we swap the sides. Not the sides, sorry. We swap the signs. Okay, we swap the sign from the positive, it will become the negative, and this one from the negative, it will come out to be the positive. Okay, so that is like a shortcut for adjoint. Actually, it's something about the cofactor, transpose. Okay, but we have a shortcut. Okay, we have a shortcut for it. Okay, so now we already have the A inverse, right? So let's go back there, right? We want to get x now, so let's multiply A inverse on both sides, right? If this is your matrix A, you multiply A inverse there, and you multiply this A inverse there too, and then it will be cancel. Oh no, not this. Like this A inverse and A, right? You multiply them, it's gonna be cancel, and you will have just x left. On the other side, you will have this -2, 5. That is your A inverse, right? -1 and 2, and you have to multiply it into this matrix. Okay, just multiplying it there. Okay, just cut it out, and then I'm gonna use the space here to get my x. Okay, let's find the answers. This one is 2 by 2. This one is 2 by 2. Right? The two nearer numbers are equal. So that if when the numbers are equal, then you can multiply them. Right? You can multiply the two matrices, and then the result will come out to be like this. Like the result will come out to be the dimensions of 2 by 2. Right? So 2 by 2, you will have like 4 members. Okay, so let's do it. So multiply it now. First row, first column, we will get the first member. Okay, so let's go. Negative 2 times 2, that's negative 4. 5 times negative 1 is negative 5, and then I'm gonna add them up. That will be negative 9. So I have like negative 9 there. Okay, next one, right? I'm gonna go to this one. This one is on row number 1 and column number 2. So I will just multiply this row number 1 with that column number 2. Okay, let's see. Negative 2 times negative 2 is 4, right? And then 5 times negative 2 is negative 10. And add them up, and it will come out to be negative 6, right? Okay, negative 6. Okay, next one, right? I go to this one now. I go to this one. This is on the second row and the first column. So I go like this. Second row, multiply with my first column. So let's go, right? Negative 1 times 2 is negative 2. And then 2 times negative 1 is also negative 2, right? You add them up, it will become just negative 4, right? It will become negative 4. And then last one, right? This is second row and second column. Let's see. Second row, second column. So negative 1 times negative 2, that is positive 2. 2 times negative 2 is negative 4. You add them, it's negative 2. It's negative 2, right? So, what is it? This is your x now, right? You have this matrix x now. That's your answers. Okay, so you start to have some idea, right? I will always teach you about the concept, and then we will just apply it into some easy example. Okay, and in the classroom, we will find some time to apply this knowledge to pad exam. Okay, what is this one? Yeah, cut it out. We don't want it. Okay. Yeah, let me drink some coffee here a bit. Okay. Oh, good one. Good coffee. What is it here? Okay. Woo. You see this, right? I wrote a lot of things with no sounds. Damn, right? So I have to start it all like over again. Let's delete it out. Let's delete it out. Let's delete it all out. So just go there, delete it all out. Okay. Now let me talk about this one again, right? Let me talk about this one again. So here it's a like if you want to work on some matrix equation like this, right? You have a times b equal to 2 times of c, right? A times b is equal to 2 times of c like that. But some students, maybe not all of them, right? Yeah, we just move something like some student will move like a to the right, b to the right, but some student will just move like c to the left, and in that student we have this one. You have this one. A is a matrix, B is a matrix, and C inwards is also matrix, right? But the other side, like that student will just have a constant of 2 left. So my question is, hey, can a matrix be equal to a constant? Huh? Impossible, right? Metric cannot be equal to a constant. So you will have an error, right? So if you want them to be equal, you have to correct it into something like this 2i, right? You have to correct into 2i because I is a matrix, right? I is an identity matrix, and if you multiply it with 2, this one will be like 2 times of I. This is matrix, right? And left hand side you have a matrix, so matrix can be equal to a matrix. Okay, so you get it, right? This one, don't make a mistake. Don't make a mistake. It's easy. It's easy. Don't make a mistake. Okay. So next one, right? Here is what I saw in exam very often. Exam will just ask you something like this: if A times B is equal to A times C, then here is not gonna be like not equal, like it's gonna ask you like equal. You know what? Exam will just ask you like that. If A times B is equal to A times C, then not but sorry, then B must be equal to C. Right? When you look at this one, some of you would just say, yes, of course, they have to be equal because this A and this A, we can just cancel them out, right? Like the numbers. Then B is equal to C. So if you go like this, damn, you wrong. You wrong. Okay, you are wrong. They're not gonna be equal like forever. Like sometimes they are not equal. So if you want to know, you can try this. You can try this. Okay, be careful. Okay, if you see this kind of thing in exam, be careful. Be careful, right? A times B is equal to A times C, but B doesn't have to be equal to C. You can check it out from here. You find A times B at here. You find A times C at here, right? You will have the same answers, but somehow B and C, they are not equal. They are not equal. So this is the thing. Like I want to point it out, and I don't want you to make a mistake. So this is like number one now. This is number one that I want you to know. Right? This next one. Next one. Here again. I saw it from the exam. Again. Again. I don't know my exam or not. I don't know. I cannot tell you. Maybe we'll see that in my exam. So the question would be like, if det A is equal to det B, then A must be equal to B. If this one is not, what should I say? If this is not a matrix, right? When you see something like this, you will feel like, yeah, it must be equal, right? But somehow, matrix, they're not gonna be equal. So because matrix is damn, like metric has like a lot of tricks, and it can really like set you up something and then let you fall into like a trap. Yeah. Okay, so if you want to check it out, then you can just do something like this. Okay, let's say that A, right? Cross down is 4, cross up is 6, so 4 minus 6 is -2, right? -2, right? Det B, okay, det B. If you want to find det B, right? Cross down is 10, cross up is 12. 10 minus 12 is the same, right? Exactly -2. So det A is equal to det B, but you go back to look. A and B, are they equal? No, they're not equal. They are not equal. So be careful. Be careful. Don't make a mistake at here. Okay. This is the second one that I want to point out. Okay. And the last one is here. 3, right? If A times B is 0, then A may be A. Okay. That is like a conclusion. But if you see this thing in the exam, it will just go like, if A times B is 0, then A is 0 matrix, or B is 0 matrix. Right? Yeah. If you go to the exam, you're gonna see something like this. Do you think that it is equal or not? I would say like no. Yes, good. I just sell an item online. Yee-hee-hee. Happy teacher, happy life. Okay. Yeah, I got some money. Okay, good. I'm doing some stuff online. I tell you, I'm gonna do it. Okay. Okay, then A is 0, B is 0. Is it true? No, this is not true. Why? Go back to look at here. If you multiply this A and B, you will get 0. Let's see. Okay. You can check it out by yourself. Okay. I don't want to waste time. Okay. You can check it out. You can check it out. A times B will give you 0, but if you go back to look, this A is not a 0 matrix and this B is not a 0 matrix. So be careful. Okay. 0 matrix means a matrix that has nothing but zeros. It has nothing but all zeros in the box like that. Okay. So 1, 2, and 3. Be careful. If you are my good student, never make a mistake on this. Okay. Okay. Let's go to the next page now. Let's go. Let's go. Let's go. Let's go to the next page. Hey, this one. Efficient way to calculate for adjoint A. Oh. know. I wrote a lot yesterday, but no sound. Long time no sound. That's good. So delete it out. Dong. This one. Yeah, delete it out. Dong. Okay, let's explain it. Let's explain it. So sometimes, like in the exam, you will see this one adjoint a lot of time. You will see this adjoint a lot of times, and then when it comes into something about the determinant like this, it's not easy to find a determinant of adjoint a. Okay, I mean it's not easy if you want to take the straight way. I mean like you do it directly without using any like formula. It's so hard because you know what? If you want to get adjoint A, you have to go for a cofactor, right? You have to go for cofactor transpose. Before you can have a cofactor transpose, you have to find minor, right? And before you can have a minor, you have to, if this is like your matrix, like you have to cut some column, cut some row out, and then find a small determinant of that thing, right? So if you want to go straight way, damn, it's not easy. So this is like the properties that you need to know right? So we're going to start it here, right? A inverse is equal to 1 over det A times the adjoint of A. You know about this one already, I know, right? If you watch my clip number 1, and if you watch my clip, not number 1, I'm sorry. If you watch my clip, I think that is clip 3. If you already watched clip number 3, then you should know about this. You should know about this, okay? Next, so for example, like det A times I is going to be equal to A times adjoint A. So what is this one? So simple, right? I tell you like this. You have 1 over det A, right? You just have to move it up there. When you move it up there, you get this one. You get this one, right? You just get this one. And here you have like A inverse, right? You don't want to have A inverse, so you just have to multiply with A on both sides. You multiply it with A on both sides, right? Then A times A inverse will give you this I, right? And this A adjoint A will stay here on the right hand side. So you get this one now, right? You get this one. So then A times I is equal to 2A times adjoint A. Okay. Next one. What is it here, right? This adjoint A is a matrix, right? You know that adjoint is a matrix. Adjoint is a matrix. So if you move it to the other side, if you move it to the other side, from A, it will come out to be like A inverse. You know, right? When you change side, it will become like A inverse. And this det A, you can just move it down there. You can just move it down there. Okay, det A, move it there. It will be 1 over det A, and then this matrix A will still be there. So you get it, right? This is like just change the side, change the form, but actually it doesn't change a lot of things. It doesn't change a lot of things. Oh, customer, what is it? Okay. And the last one, right? So if you want to get the det of adjoint A, if you want to get det of adjoint A, it will be equal to this one. Actually, there's a proof in Matrix, but I don't want to do it now. If you want to do it, maybe you can just research for it. You go Google. You can just go Google for it. But I'm not gonna do it for you. I'm not gonna do it for you. Right? Okay. So this one, det of adjoint A is gonna be equal to this one, det A to the power of n minus 1, right? And I'm gonna tell you that n is the dimensions. Right? N is the dimension of it. N is the dimension of it. So you have to go that A power n minus 1. Okay, so this is done. We are done with the concept, and we will just go for that example. Okay, let's practice it there. Let's go for example. Practice this one. Okay. Okay. Hey guys, like if I'm too fast, I'm too slow. If I make you confused, you can just capture the screen. And when we go to the class, when I see you in a class, when you see me in a class, you can just ask me there, okay? You can just ask me there, okay? I just remind you that you can always do that at any time that you want, okay? Okay, this problem, we have that matrix A, a big one, right? And then this is the conditions. This is the condition. A times B is equal to B times A, and they are equal to I. You want to find depth of adjoint B inverse, right? So this one, you have to look at this property first, right? When you see this property, when you see this not properties, you will when you see this like informations, you will know that A will be equal to B inverse, or maybe you can just say like B is equal to A inverse, right? Because let's see something like this. If A is equal to B inverse, you can just replace this one by B inverse, right? And then B inverse times B will be equal to I. You see, right? Or maybe your B is equal to A inverse. Yeah, you can just repeat this B, right, with A inverse. If you replace this B with A inverse, right? A inverse times A is I. So you see, right? So this fact gives you this information. And why is it important? You just have to look at this. It's important because you just have to look at this. You know that B inverse is equal to A, right? So adjoint of B inverse is actually adjoint of A, right? Adjoint of A. And it say you have to find the depth, right? If you want to find the depth of adjoint A, just go back there, man. You just go back there, man. Depth of adjoint A is depth of A to the power of dimension minus 1. Hey, I have an A there, right? So let's find depth A. Let's find depth A. So if you want to find depth A, right, just copy and paste something. You just have to copy and paste something, right? You want to find depth A, copy the first column, copy the second column, put it at the back. You have 1, 2, minus 1, and 2, 1, 1 like this. And then determinant is cross down minus cross up, right? Cross down minus cross up. So let's find it. Cross down, number 1. That's a 0. Cross down the second time, that's a negative 2. Cross down the third time, that's negative 2. You add all of them, okay? You have to find the sum of them, that is negative 4. Okay, that's negative 4. And then let's go up. Let's go up. So that is a 1, right? Go up there again, that's a 1. And then go up for the last term, that's a 0. Find the sum of them. You have number 2. You have number 2, right? So all the down minus all the up, negative 4 minus 2, that is negative 6, right? And then you come back here, depth of adjoint B, depth of adjoint B, okay? So depth of adjoint B, no, not adjoint B, adjoint A, sorry. So depth of adjoint A is depth A, this is your depth A, to the power of the dimensions. This one is 3 by 3 matrix, right? So dimension is 3. And then you go minus 1. 3 minus 1 is 2, right? So negative 6 square is 36. So that is the answer. Okay. So you can see that it saves a lot of time, right? So you can save a lot of time with this. You don't want to do it straightforward, right? If you do it straightforward, you're gonna waste like half an hour. You're gonna waste like half an hour because you have to find the adjoint, right? To find the adjoint, you have to find a cofactor. Before you can get the cofactor, you need to have the minor. Something like that. It takes a lot of steps. You don't have that much of time. So try to use the properties. Try to use the properties. Okay. Be happy, okay? Be happy. Okay. Let's go next one, right? Linear system. Oh, what is it there? I wrote a lot of things yesterday. Shep. Bye-bye. Right again, like. So linear system, if A is an n by n matrix, then the linear system of n equations in n unknowns can be written in the form of something like this. Aha. So n equations and unknowns. Okay, I'm gonna talk about this one later. But here is something. I have a mistake. I'm sorry. It should be like a times big X and is equals to big B, something like that. Where we call big A as the coefficient matrix, right? This one. You have to know about this word. This one of big X is the variable matrix, like this one variable matrix, and then the last one like big B. Big B is a constant matrix, right? A constant matrix. So we know all the names of it. Then let's go to example. Right? We want to know more about it. Right? Let's go. Let's go. Now we want to solve like equations, but we don't want to use elimination method anymore. Right? We want to use matrix to solve it. Yep. Delete it out. Delete it out. Delete it out here. Delete it out here too. This one delete it out here. Okay. We already delete all of it out. Okay, so we come back here, right? So we have a system of linear equation like that. That is your equation number one, right? And you look at all the coefficients, right? Coefficients are the numbers in front of your variable x, y, and z. So here you see like 4, 2, and minus 1. Put it there. 4, 2, minus 1. This is called your coefficient matrix. Like I'm gonna call it like coef. Okay, make it chart like this is a coef. Okay. Next one, like we go to the second equations. This one, x minus y is 3. In front of x, we have a coefficient of 1, right? In front of y, we have a coefficient of minus 1. But we don't have a z. We don't have a z, so that is like plus 0 z, like that. So if you go to your coefficient matrix, like you have 1 for x, minus 1 for y, and 0 for z. 0 for z, right? That's it. The third one, I think that you have a sense of it now. You feel like you have a sense of it now, right? So this one, right? For x you have 5. For y you have -3. For z you have 2. But this number one you have to move it to the right, and you can have it equal to -1 like this. Okay, this one we call it the variable matrix, right? Variable matrix. It's called the variable matrix because we have other variables like x, y, and z there. X, y, and z, we just put it there, right? And then the last one is called a constant matrix. Okay, I'm gonna call it just constant. Okay, const for constant. It's a constant matrix, and what are the constant? They are here like 0, 3, and -1. So I would just say like they are just the numbers on the right hand side of your equations. Okay, so you just have to put it there. Okay, so you know how to transform, right? How to transform your linear system into a matrix. Right? In a matrix, something like this is very like powerful, like for I would say like computer programming, something like that. We call this one like array. You know what? In Matrix4 we call it matrix, but in computer you will call it like array. Okay. And if you want to know more about it, go to study computer engineering, and you will know more about it. Okay. Yee. Next one. Gotta teach you how to solve a linear system. Yep. With the which have the numbers of equations equal to the number of unknowns. What's the meaning of that? Right? Let's see this. Right, let's see this. You have equation 1, equation 2. So number of equation is like 2. How about the number of unknowns? Like unknowns are something that you don't know, right? So you come to look, you have unknown x, you have unknown y, right? So it's like two unknowns, two unknowns. This is like two equations, two unknowns. They are equal. So when they are equal like this, it's quite simple. So you can solve for it. Right? So the idea is just here, right? The idea is here. You have ax times b. You want to get x. You move a to the other side, and you need to have like a inverse, right? Yeah, I think you know this one. We did it before. We did it in the class today. Okay, so we go now. I'm gonna move this to the right hand side, and it will become the inverse, right? I saw that your friend did something like this in the class, right? She just your friend just wrote this one there again, and then she just put like -1 on top to tell that it's inwards, right? And then this one is the same way, 5 -1. So next step, right? So that good friend of you, right? That good friend of you, we just find the inverse of this one, right? So she just go like 1 inverse is 1 over determinant, right? 1 over determinant times the adjoint. So what's the determinant? Cross down is 2, and then cross up is negative 6, right? So down is 2, up is negative 6, and then 2 minus 6 is 8. Okay, so she has like 1 over 8, right? So she just write it there, 1 over 8. And then adjoint, you have to swap 1 and 2, so it goes like 2 1 like this. And then for not along the diagonal, you have to swap the signs again. So it's gonna be 2, and that is minus 3. Okay, so you just have to copy this one and paste it there. This is the inverse, just paste it there, right? 2 minus 3 and 1, and then you multiply it with 5 minus 1 like this. Coffee a little bit, okay, sorry, I need to drink some coffee. Ah, good. I like this coffee. A little bit of water. Yeah. Okay, so let's go. Let's find the answers. Let's find the answer. Okay, let's multiply, right? So this one is like 2 by 2 matrix. This one is 2 by 1 matrix, right? So first thing that you have to check is the 2 inner number, like the 2 inner numbers. They are the same thing, right? They are the same thing, so you can multiply. And then the result will come out having the dimension of 2 by 1. Right? 2 by 1. So 2 by 1, you go. Now 1 over 8 is still there. 2 by 1 is just like that. 2 members, 1 there, another 1 there. Okay, let's see. So I want to get first member. First member is row 1, column 1. So I'm going to have the product of 2, 5 is 10. And then 2, 1 is negative 2. I add them up. I have an 8. Next one, right? This one, second row, first column. So I go second row, multiply with the first column like that. Negative 3 times 5 is negative 15. And then 1 times 1, 1 times negative 1 is negative 1. Add them up, and I have negative 16. I want to make it smaller, so multiplying this 1 over 8 inside. I'm going to have 1. No, and I'm going to have a negative 2 like this. Okay, right? Okay, so what is it here? Here is your x and y. Okay, so you have the answer now. If you want to check that this one is correct or not, this one is correct or not, you just have to put it back there in the two equations. So you have x of 1, right? And then there's y of negative 2. Let's check it out. Let's put it back there, okay? Let's put it back there. X is 1, right? So 3 times x is 1. Add it with 2 times of y is negative 2. And then it's going to be equal to, what? Like 3 times 1 is 3. 2 times negative 2 is negative 4. 3 minus 4 is minus 1. Exactly equal. Exactly equal. You can see, right? So this is correct. And if you want to check more, then you just go there. I don't want to do it now. Okay, you can just check more of it. You just put x and y there. You can check your answer. Okay, so you see, right? This is a very like beneficial something about matrix. Okay, so you can use it to solve the equations. And if you know computer programming, you can just program the computer to do it for you, and it will not take long time. Computer is so fast. You know, the robot is so fast. Okay, let's see. Let's see. The third one, right? Using the inverse method to find a solution of the linear systems. I will talk about it again. Let's see that it's a good one or not. Okay, this one is I know. This one I think that I'm not gonna delete it out, but I'm gonna just explain again, like on top of what I just wrote yesterday. So here you have this equation 1, equation 2, and equation 3, right? And you transform them into this one, coefficient matrix. So you just look for the numbers in front of x, y, and z. This is coefficient matrix, so you just write it there. Next one, this is a variable matrix, x, y, z, right there. Constant matrix, like constant matrix consists of 3, 1, and negative 2. Just put it, just have to put it there, right? You have to put it there. Okay, so next one. You want to find this x, y, z? You have to multiply these matrix, like inverse of this matrix on both sides. You multiplied it on both sides, then you can have x, y, z equal to inverse of this times 3, 1, and minus 2. Okay, understand it, right? Understand it, right? And this one, the inverse of this one is going to be equal to like 1 over the determinant times the adjoint matrix, right? I did it here because I did it on a paper before. I want to save the space. I find the inverse of this matrix already, and I just write again there, right? It's multiplying with that. And if nothing is wrong, like you multiply them all, something like this two, right? This number is on the first row and the first column, so you go multiplying this and that, right? Okay, you go multiplying something like negative 4 times 3 is negative 12, right? 4 times 1 is 4. 1 times negative 2 is negative 2. You add all of them. It comes out negative 10, right? Negative 10. And then this negative 10, you have to multiply it with that constant. 1 over negative 5. So we'll just like cancel, and then you will have number 2 out. Okay. So you just have to do this one like again, until you get y and you get z. So x is 2, y is 0, and z is minus 1. That is how you solve your linear system using the matrix. Okay. This one I want to save the time. Okay. I don't do other step. I give you the core concept. If you have the idea, you can just work on it by yourself. Okay. Next one, Kramers. I like this guy very much. This Kramer guy is so damn smart. Okay, let's explain it. Let's explain about Kramers. So I'm gonna do it again. Kramers, this one. Let's do it again. Like delete the old one out. Bye bye. Okay. Explain again. So in solving any like linear system, Kramers rule is so damn like useful, and you're just gonna have to use it again. It's gonna be about the determinant divided by another determinant, right? And I will just tell you what is AI, what is dead A. Okay, let's see this from this example. You have this linear system. It's equation 1. This is equation 2, right? You transform equation 1 and equation 2 into this coefficient matrix, this one variable matrix, and this one constant matrix. Transform 1 and 2 into the matrix system. So Kramer said if you want to get like x, you have to do like this. Find a determinant, right? Divide by the determinant like this. So let's start with this one, easy, right? A is here. Yep. This is your like matrix big X, and this is your matrix B. Okay. So det A is like 1, negative 2, 3, 2. Find the det of this one. AI, right? AI means like this. You want to get X. X is the first member at here, right? X is the first member at here. So you want to replace this one, like first column. You want to replace this first column with this one. Just replace it there. You want to get this 5 minus 1 and then minus 2, 2. Okay. So this is how you get like AI, right? How you get AI. Okay, find the determinant now. Start with this one. Like down is 2, up is minus 6. So down minus up is gonna be 8. This one down is 10, up is 2. 10 minus 2 is 8. It's the same thing. Chip chip. So your egg is now 1, right? Your egg is now 1. Is it easy? I really like Kramers. Kramer is good. Kramer is so good. Like, now you already have y. You already have x, right? If you want to get y, then again you find determinant of ai divided by determinant of a. This is like that a, right? This is a determinant of like ai something. Okay, so let's see. Let's see. Now you want to get y, right? Y is the second member. Y is the second member. So you have to replace this second row with that constant matrix. Okay, so it comes out like this. You know, right? This one is the same 1, 3, but this one is changed to 5 minus 1 like this. And then divide by determinant of A. We did it there already, right? Determinant of A is 8. Just put it down there and do the math. Okay. So cross down is minus 1, cross up is 15, right? Down minus up is negative 16. Divide by 8. Then you have negative 2, right? So your y is now negative 2, right? Let's go check it out, right? That it's correct or not. Like, check it out. Let's see. Check it out. That here, right? So x is 1. So I'm gonna write 1 minus 2 times of y. Y is negative 2. I write it there, negative 2, and equal to 5, right? Is it equal or not? Let's see. 1. That negative 2 times negative 2 is plus 4. 1 plus 4 is 5. Yeah, correct, right? This is correct. If you want to check more, you just have to substitute there. I don't want to do it. I want to save the time. I want to go forward with something else. Okay, so this is Cramer, right? This is so fantastic. Right? This is so beautiful, so fantastic. You applied it in your exam. Right? When you do it, you can save a lot of time. You can really save a lot of time. Yep. And what is it here, right? It say in case that the value of a variable is found, then it can be substituted in any equation in the system to find the solution of the remaining variables. So what's the meaning of this? Let's do it with the red color. This one means that something like this. If you get x already, let's say you use the Cramer's rule and you get x already. This is your x, right? X is 1. So instead of doing this Cramer again, you know, right? You do a lot from Cramer, it will become like crazy. You just have to substitute your x there. If you substitute your x there, what are you going to have, right? You will have like 1 minus 2y equal to 5, right? So, and then you move 1 is still here. This number 5, you move it to the left like this. Minus 2, move it, will become 2y on the right hand side. This is like negative 4, and that is 2y. So you know exactly that your y is going to be negative 2. Yep. So you see, right? So the meaning of this long sentence is if you have one variable, don't use the Cramer again, but you just have to substitute what you know into the original equations to get another one. Okay, so this one works faster. This one works faster. I would say works faster. What's happening? Like, why is it a lot of this? Okay. Customer. Yep. So happy day. Happy day. Okay. So, oh, what is it here? You want to apply the Cramer's rule to find a solution of a big system like this. Okay, a big one. Right? So take it out. And then we are going to do it again. We are going to do it again. Right? Okay. So you transform equation 1, equation 2, and equation 3 into something like this. Transform it, right, into a matrix form, right? And if you want to get x, right? This one I have x of 2, and how can I get x of 2? Like let's try to do it here, right? You want to get x, okay? So you have to work with ai, right? So ai is gonna be something like this, okay? Okay, I'm gonna write it here. X is gonna be determinant of this one, right? Not okay. X is the first member, so okay, let's do it again. Okay, I want to get Okay, let's start with that of A. That of A. A is there, right? A is there. This is A. This is A. I want to get that A, so I have to go 2, 1, negative 1, 3, 2, 4, 1, 1, 0, like this, and then copy 2, 1, negative 1, 3, 2, 4 there, and I would just have to go like cross down, minus 3, cross down again 4. Right? Sum of them is 1. Cross up is minus 2, cross up is 8, cross up is 0, add all of them, it's 6. So cross down minus cross up, then I have it negative 5. Okay, so I have negative 5 for the delta of A now. I have delta of A equals negative 5, and then I'm just gonna keep it because I know that I'm gonna have to use like that A like again and again like that, so I just keep it. Okay, next one, right? Now we're done with this, right? Now we're gonna find this det of AI, right? We want to find x, so x is the first member, right? X is the first member, so you have to replace that first column with that constant matrix, like 3, 1, and 2. So you replace it like this: 3, 1, negative 2 in the first column, right? Second column, nothing is changed. Third column, nothing is changed, everything is fixed, and then find the determinant. 3, 2, 4 like this. Okay, so you go again like down 0, down minus 6, down is 4. Add all of them. Add all of them. It's minus 2, right? Up is minus 4. Up is 12. Up is 0. Add all of them. That is 8. That is an 8. An 8 or not? Yeah, it's an 8. So down minus up, right? Down is minus 2. Minus up 8. So that of this is equal to minus 10. Right? It's equal to minus 10. So come back here to x. So we have a det of AI negative 10. Right? We have det of A negative 5. Chip, cut it out. You have your x of 2 now. Easy. Easy. So easy. Right? And now you just have to go back and use the rule. What is it? What's happening? Okay, something is not okay. What's happening? Oh, damn! It's slow. It's like kind of delay now. It's gonna be okay, right? I don't have to make it again, right? It's kind of delay. So you want to use this one, right? You want to use this sentence again. So now we know that. Now we know that x is 2, right? So you just go back to those equations, and then you see that, hey, the third one, right? This is the third one. The third one has only like 2 variables, so you know that this I'm gonna change to yeah, blue color again, right? So you know that this one is 2, right? X is 2. X is 2 now. So you just have to replace your x with 2, so it comes out to be like negative 2, right? Okay, maybe write it here: negative 2 plus 4y, and that is equal to negative 2. So you see that here is negative 2. Here we have another negative 2, right? So if you want them to be equal, then this 4y must be 0. So if 4y is 0, you know, right? Negative 2 plus 0 is equal to negative 2. So this 4y must be 0. If 4y is 0, then your y is 0. That's why I have it here. Y is 0. So you see that? So now you have x of 2, y of 0. If you want to get z, so you go back, maybe equation number 2, right? Substitute your x, like x is 2, y is 0, so it's gone there. So now you have like 2 plus z is equal to 1. Yeah, right. Maybe write it here. Like 2 plus c is 1. Then your z is minus 1. So get it, right? That is how to use a Cramer. That is how to use a Cramer. Yeah, I wrote something here already. Okay, but it's okay. We may not use it. So you get x of 2 by the Kramers, you get y by the substitutions, and you get z by the substitution. You know what? Kramer is good, but to use the mix of all the goods is the base. Okay, use the mix of all the goods will be the base. Okay, base of both, yeah. Somebody would just say like it's the base of both. Right? Ah, okay, so we are done already, right? We are done already. So I spent about like 55 minutes, okay? So I'm gonna stop it here on page number 17. And please try to get it done before the class when I see you on Thursday or maybe Friday. It depends on the class that you are like depend the class that you are. So I will check it up to page number 17. So please get it done. Okay, please get it done. So bye bye everyone. I want to stop here. This is Teacher Ed, and I will see you in the classroom. If you have any questions, ask me. I will always be there to help you. Bye bye.